Hey, hi. How have you been?
Hi, Shunyun.
Yeah, good, good. So how have you been?
I've been good. How are you?
Okay, good, good.
Have you
Just had
been?
lunch here.
Oh, nice.
But
Nice.
assume you haven't started breakfast or you've eaten already?
You mean the?
Breakfast? I mean, usually you have breakfast before or after this.
Yeah, yeah. I'm just having tea. Not,
Oh, I
I've not
see.
really. Yeah,
Oh,
I've
I see.
warmed up the food and everything, but I'm gonna
Okay,
have it after this. Yeah.
okay, I see. All right, good, good. Okay, so yeah, so Herman probably will attend another meeting, right, on Thursday,
Yeah,
isn't it?
yeah. I think so.
Okay, so I
Yeah.
think we can start. Okay,
All
so
right.
how, just to get your feedback, how was yesterday's interaction?
No, I
With
think
the,
it was very good. It was.
okay,
I think I even felt special and stuff because
okay.
because it sounded big when you put it on a big picture. It sounds like wow, okay, it's quite impressive. But anyways,
Okay,
but yeah, I
okay,
think I'm quite excited about it as well.
okay, nice, nice. Okay, so
He
did you
sent me his
guys,
email address.
okay, okay, nice.
So we were supposed to sync yesterday, but it was quite tiring, and also I didn't really have much for him at the time, so I
Okay,
was like, let's reschedule.
okay,
But we
okay,
do have a plan to meet this weekend. I
okay,
don't know if you
sure.
heard about the hackathon weekend,
Mm-hmm. Okay,
just to
okay, I
try to
see.
get as much
Okay.
done over the
Mm-hmm.
weekend because
Okay, great.
there's a holiday, so it's
Oh,
like
okay.
take advantage.
All
But
right,
he is
great.
quite interested, and yeah, it's looking good, I think.
Okay, so thanks, Victor, for
Uh,
inviting him on board. I think
oh
it's
yes,
yeah, you also play an important role
uh,
in terms
thank
of
you
right.
as well
All right,
for the
so I think
opportunity.
we can get started. Okay, and
Yes.
okay, discuss about the current status. Okay,
All right.
all right,
Let me just share my
go ahead.
screen. All right. So progress has been made in
Okay,
terms of,
nice, nice.
uh, but there's a bigger problem.
Okay, that's always
Like,
happen.
yeah, like as you write your code, then I realize, something is off.
Right.
But I will let you know. Let me just try to paint a
Okay, so
picture quickly.
that's fine. Just yeah, what is the current status?
What's
Mhm.
so at the moment, let me just put this. What I did was I created a file called network interface.
Okay, okay, nice.
So the net interface basically what it does is there's a send and receive function.
Okay.
And first there's a universal value. Sorry, let me start here, which
Mhm.
is to switch sim mode, switch between modes basically.
Okay.
So the idea is if sim mode is true, so
hmm
I'm going to look for a way to make this universal across
hmm
all files.
Okay.
But for now, I'm just using a temporary,
Okay,
variable
sure.
in this file. So it's
hmm
if sim node is true, the idea is perform some functions, and if it's not true, just use the normal method, right?
Okay.
So the idea here now is, if there's a function to send and receive.
hmm
So for send and receive, if sim mode is true,
hmm
then simply print that,
Right, right.
like print sim mode active
hmm
and the data, and basically estimate the length of the data. So the reason why I do this length part
hmm
is, if you remember in our initial when we were drafting document, the idea was if it's a subscription request, you're gonna get
Okay.
an IP and a channel,
Right, right.
and if it's a publish request, you're getting.
hmm
I mean, sorry, yeah, yeah. If it's publish, sorry, you're getting three, a length of three items,
hmm
which is your ID, your channel, and your message. And if it's a
Okay.
subscription request, you're just getting two. So this is just to
Okay.
check if it's a subscription request or a publish request.
Okay, I see.
So basically, this message is what is collected from the node. So instead of the node sending directly over the network, the node is sending um, to the to the net interface.
Okay, so the net
It
interface
connect
there.
yes to the network interface. Yes, so it's a
hmm
network interface that decides if it's in simulation mode or
hmm
in experiment mode. So the same thing with the subscribe request as well. If
hmm
it's a subscribe request, send it um, to the what do you call it, to the network interface. Just
Okay.
the request. And this is the check-in part if the request is a sub or a pub. So if it's a sub, if it's in SIM mode, simply just pass the data to the matcher through the local, import export library function.
Okay.
Right. But if it's in experiment mode, basically you want to listen. You want to basically, so there's a whole process. The idea is you're connecting to a certain socket. So this is using socket now, connecting to the host and the port. And the host and the port here would have been defined by the IP.
Right.
I need to fix that. Sorry. And basically, once it's connected, say, it's connected, and wait for the data to basically wait for the data, right?
Okay.
Wait for the response. And once the response is received, send that to the function that handles the message received.
Okay.
So once this happens, once this is successful, so it goes to the matcher either through the network or through the local connection now. But here there's also the universal variable, which is SIM mode.
Right.
So the idea is if SIM mode is active, basically perform the process in the matching process. Where is it now? I didn't take it out, did I? Oh yeah. So remember this this part sends the information to the matcher. So the matcher receives the information whether through simulation mode or network code. It doesn't really care how it gets it, but it gets it. So the idea is after it gets it, it does the matching, right?
Okay.
And once the matching is done, the result from the matching, do the send response. That's the part.
Okay.
Send the response to the relevant party, right? And the send response function, what it does is it gets the ID of the relevant party as well as the relevant message, right? So it also now checks now if it's in SIM mode, send the information back the local way, or if it's in experiment mode, use the network connector, which is the socket, and use the sub ID, connect to basically to the sub ID, in this case, which would be the IP address, subscription IP, as well as the port, bind the success message. If it's connected, just say success and append the publisher message, and done. So the idea behind this now is once the matching is done and successful, yeah, if there's a match found, send the response either through the network or through the through the to the local files. Let me just put connectors, right? And then there's this part that now receives the message, right? I'm trying to see. Oh boy, I think I deleted something here. But then, so the idea here is it's supposed to now send the message back to through the net interface to the node. So the message sent here will be received here and sent back. So there's supposed to actually be a network. I think I deleted something here. So there's a network thing that happens here. There's the network response or handling, basically, where it says, okay, I'm expecting data to be sent through a certain server here, and basically sends that received data to the node, back to the node, which will be the message handler, the handle response. Now, the bigger problem, which I think is probably a priority, I noticed something in my code when I run this method. It runs this node as one. So it's like one node processing 5 IPs.
That's right.
And not and not 5 IPs and 5 nodes. And that's a serious problem. That's one. And the second problem is I actually want, like, once the node is created, the ID should be unique, the ID and channel. So the ID received at the publish node should not be different from the ID and channel in the subscribe node, because it's one node. They both have similar IDs and channels,
Okay.
right? The only thing that sort of changes is, am I making a subscription request or a publish request?
Okay.
So I have started it. I'm still trying to picture how it's going to play out, but the idea is, so for this IPs, generate a unique, identity, which is ID and channels,
Okay.
or channels it wants to subscribe to. And then when there's a sub request, right, then, collect it. And when there's a publish request, collect the publish, the array. And the idea now is the message is going to be generated in a different layer or function. As to what the message would be, someone, that sort of is defined in a more realistic scenario as to what kind of messages it's each node is generating. Maybe we can say node A is generating temperature, node B is generating pressure. And then the idea in this node generator is, you have the ID, you have the channel, and then there's a link to the generator message, or the message generator. And the idea is, once the nodes are generated, then this is a pub request, right? Where it's saying, okay, I want to send a request. So it's like a flag, and not necessarily what do you call it? So instead of saying that, it's going to be something along the lines of send p node, something like that. Sorry, but I don't know if you understand what I mean. But the way I know this is not matching, or this is not the same, is I try to get the identity of the object in this case, where I'm saying, okay, when you get a subscriber node, call this is the S node ID, and then get the identity of this object, which is a class. And if you notice here, it's the same thing. This is supposed to be different.
Okay. Okay.
The S node should be.
All right. So basically, you're saying you're using a P node, for example, to encapsulate the request, right? Basically,
Yes. Yes.
like a publish or a subscription request.
Request, yeah.
And I can see that you are sending. Well, I think it's good that you have a structure now. Okay, I think it's quite with a good, with a structural way, and the and you're okay, and I can see you through. You have this function called send and receive, right? That you are sending this to basically allow it to handle the request node, right? And you're doing this apparently for both the publication and subscription. Is that correct?
Yes.
You're calling this, right? And for it to basically deliver that to the matcher to be processed, right?
Exactly.
Okay. All right.
Yeah.
So I think the main, again, the main logic, the flow of the the steps is generally correct. Okay.
Okay.
The one thing I like to feedback or point out is, well, for one thing, if you are just, whether it's a publication or a subscription, this is just sending this to Matcher. So it doesn't have to call. It's actually not a send and receive. It's a send. Okay.
Yeah.
This is really just send. This is just sending something. It's sending. It's not receiving. Okay. Receiving is probably something you will have to handle separately.
Separately.
Yes, probably somewhere separately, because usually for send you are in an active role, right? You are executing a logic to send out. But usually for receive, what happens is you put up or install a listener or a handler, that sort of handles the incoming message in a passive way. Okay, that's usually how these communications, network communications are being done or handled. Okay, it can be in a form of a callback, a form of a pointer, a form of a register listener. Okay, but regardless of the format, the concept is the same. It's a passive handler of incoming messages.
Yeah.
Okay, so that is something I think you probably conceptually have to separate. Okay, so the send and receive is essentially a send. Okay.
Okay.
However, when you are doing a send, then I can see that you are encapsulating, for example, the S data, right?
Yes.
It's really I think a publish and subscribe request, you know, and for this, okay, I think this is a little different from what I guess what I was imagining the network layer would do. Okay.
Okay.
The reason being, okay, right now, what you're saying essentially is whenever you do a send, you do a send, okay,
Yeah.
which is your send and receive function. Okay. Whenever you do a
Yeah.
send, you are sending this only to a single node, which is the matcher.
Yes.
Okay.
Yes.
It's as if there's no other target, no other nodes that you need to send to. Okay, you see?
Yeah, I see.
Okay.
Yeah.
But I don't think that assumption, I mean, in the particular case of a client node, okay, that is actually true. Okay, because I think in our current design for other clients, they just actually all they need to do is just connect to the matcher. Okay, and that's it. Okay. However, for a matcher, for example, it needs to connect to first other matchers. It also needs to connect to, be able to connect to, many clients. You see?
Okay.
So in that sense, your network layer has to be sort of designed in a more generic way. You see that point?
Okay.
Okay. So what this means translates into detail is that in the send, I would consider the S data that you are putting as parameter. It's actually just a payload.
Okay.
Because it doesn't really specify like who am I sending this to. Okay.
Yeah.
Okay. So if this were to be a network interface, which is what this class is about.
Yeah.
Right. Okay. And you are having a physical network and also a virtual network, both, right? Then what happens is you need to be basically for network interface, at least 3 functions I think are needed. One is connect. Okay, meaning that you want to initiate a connection to another node, given that node's IP port, whatever, right?
Yeah.
And you need a function to send. Okay, to send to a designated target.
Okay.
Okay, you see? And you need a way to receive, right, or process the incoming messages.
Okay.
Okay. So those are the 3 main functions I think, any network interface should include.
So
so
I see what you. So the idea basically is breaking this down into functions, because I think everything is actually in this one.
What you have the send and receive is fine, although that is actually just the send. Okay. Okay. And also the second thing is I think you need one more parameter besides the S data, because S data really is just the payload actually. You need to also specify like which node, like a node ID.
Okay.
You see?
Okay.
Do you see what I'm saying? Like when you're sending it to a matcher, you should not have the matcher within your network interface. This is also logically not correct in the sense that the network interface should be oblivious, in the sense it should be ignorant, or it doesn't have to have understanding about things like matcher, you see. or a client.
Okay.
That's right? I mean, TCP/IP doesn't know what a matcher is. You see, matcher
Yeah.
is a concept that exists above the network layer. Is this making sense?
Yeah, it is. It is.
Okay,
I see the logic.
You see the logic? So when you
Yeah.
have a object or a variable called the matcher within the network interface, okay, that is already telling you something is not
Something is
correct.
wrong.
You see? Do you see that? Do you see what I'm saying?
Okay.
Network interface, it actually is a lower level in terms of the abstraction. You see? Because what happens with the network interface is you are encapsulating, you're abstracting away potentially a physical TCP connection, a physical network, right? Communication on the physical network, or a simulated network that you basically made out of maybe a bunch of queues or a bunch of arrays. Okay, as a simulated network layer. And the network interface provides the abstraction to utilize the underlying functions. Okay, but the concepts you see within a network interface should be things like IP, port, or node ID. Right?
Yeah.
You see, and payload, and that's it. Okay, everything else should be something that's being handled by the layers above that. Does that make sense? Sense?
Yeah, I think I see what. So at the moment, it's like this interface is like on the same layer as the node and the matcher, which shouldn't be. It should be abstract.
Exactly, it's doing too much.
Like a Java interface.
It's doing too much. It's doing and knowing too much. When so it's basically, in fact, it should just be very, very simple.
Very send, receive, what's the
and
word?
Connect.
Connect.
Well, connect and disconnect. Well, with connect, you have disconnect, right? When you connect, you probably have to specify like the IP port plus, and maybe the node ID is something that's assigned, you may not have to assign that. You will maybe get that as a return value somewhere, right? And you can disconnect, right? And when you're send or receive, maybe you're just using a node ID to represent the target node you're sending to, right?
Sure, I see.
You see?
Yeah. Okay. Okay, I do see what you mean.
Okay. Yeah. So I just like to clarify this. Okay. So
okay.
And
so
any
practically all
so
of
far?
this. Yeah. So it means in theory, all of this logic should actually come to the node. The network interface is simply just sending. It's like you're calling it's like a bridge of some sort.
Exactly.
Okay.
That's right. You're right. Yeah. It is a bridge. It's a, you can think of it as a bridge that connects the message queue between different nodes, right?
Yeah.
When you send, what you're essentially doing is you're putting up a message in the form of packet and put that into the receive queue or the to be processed queue of the target node, right? If you think of it that way, it's literally that you're just putting a message to another node's, message queue, right? That's waiting to be processed, right?
Yeah.
And and for receive, what receive does is simply to fetch whatever message that has been left by other nodes into my own message queue, right? And I will process them one by one. Something like that, right?
Yeah.
You see?
Yeah. So, okay.
Okay.
Yeah, I see what you
mean. So is this making sense?
So it's basically like receive, and then instead of S data, you're basically having something like ID and port.
And the payload.
And the payload, yeah. Payload, ID, payload, yeah. Okay.
And for as far as the network interface concerned, it actually doesn't care what you have in your payload. It's just a bunch of bytes. You see?
Yes.
It doesn't need to know or understand
Packets.
the structure, okay,
Yeah.
within that. That is entirely up to the upper layer to interpret.
To interpret what it is.
Yes.
Okay.
Okay.
Makes sense.
All right. Okay. So I think for the weekend, for before next Monday, what I like to see is to fix the current issues and to really make the network layer work. And I also would say to just focus on the simulated network part. Okay. Just try to get that part right. And the physical part, the actual TCP/IP, the socket part, I think you can either add that later, or maybe you can discuss with Anisio, right?
Okay.
Right, about whether it's something that he might be able to help, or if there are other aspects. Okay.
All right.
And I'm also one thing also to note is you might need an initialization part to the network interface as well, which is to simply to obtain or create a unique node ID when the network interface of a particular node initialized.
Yeah.
Okay.
Yeah.
This is something that can be done, in the simulated network. It's pretty easy. Just create a node ID for each. In the physical one, it probably would involve you to either generate one using something like UUID, okay, or maybe to request one from a centralized directory, such as a gateway server.
Okay.
Okay, does that make sense?
Yeah. Yeah.
Okay, so I mean, this is just another small detail to note.
Small detail. Okay. Yeah. No, that's fine. That's fine.
Okay, so I think for is it okay so far?
Yes. So absolutely, yeah.
Okay. So yeah, any questions? I guess.
No, for now, I think I see what you mean. In terms of that basically went. It's completely different from. Thing is, I practically everything you're talking about should be in a function, but I think I did everything in just one line, where there's a connect. So yeah, there's listen here. Yeah. So I need to find a way to break down the simulated. But it's fine.
Right.
I understand.
Okay, and also the length, checking the perimeter to decide whether sending that is not really needed. Okay.
Okay.
if you because again that is you are checking parameter size while the network layer it should not be bothered with like how many parameters are being put into the payload, right? You see, that is always the task, the job of the upper layer. Okay, all right.
So
does that make sense so far? Yep.
Yeah, it's the matcher that checks if it's okay.
So please, for next Monday, try to fix everything and make sure that the network layer can work as intended. Okay, that it supports send and also receive. Okay, and also can maybe connect to another node and initialize its node ID, things like that.
Yeah.
Okay.
All right. Yeah.
All right. Okay. So I guess any other questions?
For now, I think that's more or less it for now. I'm gonna go into this to try to fix.
Okay. Is this just a quick question? I mean, how do you feel? I mean, is there a sense of frustration or?
No, I mean, not. Yeah. How do I say frustrated? The thing is, I sort of know what I need to do.
Okay.
It's a case of when you go to the computer, and then you try to implement the theoretical flow, that's when, you know, then it gets more
all right.
complicated, and then you start seeing
There's
problems.
a quick way is that just run your code, try to run your code, you know, and you will get feedback very quickly.
Okay.
Yeah, although when you have logic error, you might, you know, find problems that you're puzzled about how to solve. Okay, so at least try to make sure the structure is right. Okay, and then you will be you will debug easier actually, you know, because when you're clear about the structure and the actual logic, it'll be easier to debug. All right. Okay.
Yeah.
All right. So thanks, Victory. And
thanks so much.
I'll talk to you next Monday then. All right.
Monday. Yes.
Okay.
Yes,
Yeah.
definitely.
All right. Okay. So have a great weekend and look forward to our next scene. Okay.
Yes. You too.
All right.
Okay. Thanks so much.
Bye-bye.
Bye.
Bye.